Alright, I guess I'm going to do this for the second time because apparently when I use the camera, it doesn't keep recording. So anyway, section 3 is talking about how to get information from the graph of a function. So I got to click over a couple more slides here just because I was messing around. I wasn't up to it. But anyway, the picture is going to be on there and it's going to say how do you come up with some answers from this. So the first one it'll say T1, which means 1 down here, go up to here, where does it hit? And it corresponds with 25. So the temperature is 25 degrees. According to this problem, same thing if it were to ask you for 3, 4, 5, whatever, it's going to just basically you're going to correspond it with the side along, or do it with the numbers along the side, and then you have your answer. So that's how you read a graph. It'll ask you things like which one's larger, T2 or T4. Well, that's just looking at which one's higher on the hill. T2 is definitely the higher one. It'll say which one's equal to 25, so I can draw a line at 25 and say it's at 4 and it's at 1. Or I could say which one's larger than it, and it goes from 1 to 4. So just so that you guys know, as far as pulling information off of a graph, we're basically just going to look at it. You know, again, if it says T6, we go over to 6, we see that, we roll the line over, it corresponds with it. Looks like it's around 17 or 18. So as far as reading a graph, you know, that's how you read the graph. From there, what we're going to do is we're going to find the domain and range of a graph. Now, domain refers to the x values, and the range refers to the y values. So what they will do in a problem is they will say sketch a graph with your graphing calculator. F of x equals the square root of 4 minus x squared. And when you do that, you'll get something that looks like this. Just like that. Then what will happen is that you'll have this on your graphing calculator, and then it's up to you to kind of determine where they are. When it refers to x values, they're referring it from left to right. That's how they work. It looks like it starts at 2 and ends at, or negative 2 and starts at, or ends at positive 2. So my domain is going to be from negative 2 to positive 2, according to the picture. Then the range goes up, or I like to say from ceiling to, or from floor to ceiling. So for this particular thing, the range is going to be from 0 to 2, according to what the picture shows. So just so that we know, that's how we're getting at. When we look at domain and range off of a picture, we're just looking at where do they, how high does it go? That's the domain and range, or the range part, and how far left and right does it go? That's the range part, so, or the domain part. So, as far as finding domain and range, that's what you're going to be looking at. How does it go from left to right? How does it go from floor to ceiling? Then from there, they're going to ask you to solve these graphically. And they're going to give you an equation that says 2x plus 3 equals 5x plus 6. Now when you have an equal sign, what I do is I put this as y1 and this is y2, which means I'm going to put 1 into y1 and 1 into y2, and because of the equal sign, we are going to see where they cross. That's what's going to happen. So when I sketch the graph here, again, I've already put this in my graphing calculator, and I got a picture of a parabola that looks something like this, and I got a picture of the line that looks something like that. Okay. Now, according to it being equal, we're going to try to find where does it equal. Now, for this particular piece, try not to just guess. You know, some people hit the trace button and the trace will get it close, but not accurate. On this calculator, it has certain features on it that will actually do things for you. If you hit second and the trace button, there will be a drop-down menu that says value. That's if you want a specific value for x, you can put that in there. Then it'll say 0. 0 is another name for where does it cross the x-axis. minimum, maximum, which is the high point and low point, which we'll talk about here in just a few minutes, and then intersect, which is what we're going to use here. Intersect means where is it cross? Well, that's what we're trying to find. So what you're going to do is you're going to go down to option number 5. And now here's what's going to happen. When you select option number 5, it's going to come up with a blinking cursor right about there, and it'll say, are you on the first curve? Or it'll say first curve question mark. And what it's asking is this the first curve? Yes or no? If it is, then you hit enter. So it'll say first curve. And if you are, you hit enter. Then it will say second curve. And if you are, you hit enter. Then it will ask you to guess. And this used to be way back in the TI 81, 82 phases, that the closer you were to the ordered pair, to the crossing, the faster it would go. 83s and 84s are fast enough, so they will go through them pretty quickly. So you don't even have to guess. You just have to say enter. And again, the cursor would have been blinking about there, and then it will give you this one right here. It will not give you 2 at the same time. It will only give you 1. Now when it does this, it gives it to you as an ordered pair. We don't want an ordered pair, we just want the x coordinate because there is no y in the original problem. That x coordinate is negative 0.5. Okay, so that's what it should give you for that. Then in order to get this one over here, you have to run it a second time. But what you do is, once you go to the first curve, you hit the right arrow and you move the cursor closer to that point. Once you get that cursor closer to the point, it will find the one that it's closest to. So for instance, if you have it a long ways away, it ain't going to find it. So you got to be closer to it. So then therefore you would have x equals 3 for the other one once you run the first curve, second curve, and guess. Now, what they could do is they could also change this up. What if they say, when is this greater than it? Well, the parabola is the first part, and the reason why I knew it was a parabola is because it's x squared. So as far as the green circles go, now it's bigger than it there, which means it's on top of that line. So if I was doing the green one, I would say from negative infinity to negative 0.5 and 3 to infinity. Now the reason why I have parentheses on all those is because it did not say equal to in the original, in the green problem. Okay. Then if it goes on to say less than or equal to, now it wants when's the line on top of it. So in that one, the answer would be from negative 0.5 to 3. And I do have the bracket on there because it had the equal to sign. So just be careful with the signage as far as what the signs say and whatnot. So as far as solving an equation graphically, that's what I do is I put one side into y1, one side into y2, and then either if it says intersect or equal to, I look where they intersect at. If it says less than or greater than, then I look for which one's high, or where is it higher or lower than it. So that's how I use the calculator to do that. Then after that, they're going to ask you for increasing and decreasing. Now, the next thing, 2 things I'm going to talk about at the same time. Increasing and decreasing, and also mins and maxes. And the reason why I'm doing it at the same time is because it's important, because you got to do both anyway. So what will happen is that you'll have a picture that'll come in here like this, and it'll say identify the local minimums and local maximums. And what that means is, where are the high and low points at? So for instance, right now I have a high point here, so that would be a maximum. I have a low point here, which would be a minimum. Oops. And I have a maximum here up there. Now, what we want to do is we want to actually find those ordered pairs. This is in the same spot that the intersection was at. So if you hit second and trace, it's options number 3 for minimum and option number 4 for maximum. Min, max. Now for this first max, what it will do is, depending on where the cursor is at, it'll try to put it on the y coordinate or y intercept. So if this is my, let's say those are my axes. This is where it would put the thing right there. And when it's asking for min and max, when you do that one, since I'm going to find the left one first, I would go second trace, I would go down to option number 4, and now it's going to ask you left bound. Now left bound means physically is this cursor blinking left of where it is a high point? No. So what we do is we hit our left arrow so that we get on the other side, so that's somewhere over here. Once it's to the left, hit enter. Then it will ask you to the right. And then you move it back over to the right, hit enter, and it'll ask you to guess. You don't have to guess, and then it will come up with an ordered pair. Let's just say that that ordered pair is -2. How high do we want to go? 1, 2, 3. We'll say 3. So that is the local maximum ordered pair. Now, when they say that, they're going to say, what is the local maximum? 3, and the x at which it occurs is -2. So just so that you know that there's a couple different ways to interpret that. Then in order to find the next one, the minimum, I do the same thing. I go second trace, but this time I'm going to go down to option number 3 because it's minimum. And now the cursor will be blinking, and I'll do this one in green so we know. Cursor will be blinking up here. Is this left of it? Yeah, but I usually like to move it down here around this area. And then it will ask, once you hit enter, it'll ask, are you to the right? So then you move it over here, hit enter. Guess, nope, just tell me the answer, and we'll say that's at 1, 0. Now here for this one, let's be careful with that, because if it says 1, 0, it might say 0.999999999 and then like 2.347 e to the -12th. When you see that 0.99999 like that, that's 1. And when you see that 2 point whatever, don't be trapped by that, because look at the e part. If it says like 2.34567 e to the -12th, this right here is scientific notation. That means 11 zeros in front of it. That's the same as 0. So just be very careful with that. Just depends on when it was programmed back at Texas Instruments what it actually gives you. It might even give you 1, 0, but sometimes it doesn't. So just be careful with that part. Then 1, 2, 3, 4, and we'll say this one's at 4 and 2.5, just because. Okay, so again, we found the mins and maxes using those menus. It will not do all of them at the same time. You have to do them individually. So unfortunately, you got to do them at different times. But that's what you're going to do to finding the mins and maxes. The second half of that problem would say find the intervals at which it's increasing and decreasing. I look at this as like a roller coaster ride. We start over here. We're increasing. We're going up the hill. We're increasing from -infinity to -2. Now, the 3 does not play anything into this because we are not dealing with the y coordinates of this, only the x's when it's asking for the intervals which it's increasing and decreasing. Then once we hit that -2, the roller coaster goes down to 1. So this would be a decreasing. So then we'd have another line that says decrease, and we'd say from -2 to 1. And then it goes back up the hill from 1 to 4. So then we're back over here, we're saying 1 to 4. And then we're decreasing from 4 to infinity. Now a couple things I want to point out to you. If you notice that all those were actually parentheses, and the reason why I've gone to that is in talking to a number of colleagues of mine, especially in the science area, when they talk about velocity and whatnot, and instantaneous and certain points like that, if that was mirroring like a ball, for instance, you throw a ball in the air at the highest point, it actually is not increasing or decreasing, it's motionless, so to speak. So that's why I've gone to just being all parentheses rather than brackets on any of those. So that's how you do the increasing and decreasing. That's how you find the minimums and maximums. As far as section 3 go, that's all they're going to ask you to do. They're going to ask you to solve it graphically, which means you'll find the intersection. They're going to ask you for the mins and maxes and the intervals in which it's increasing and decreasing. Intervals, again, remember, go from left to right, and they're only the x coordinates. The mins and maxes are actually finding the minimums and maximum points using the calculator and coming up with the ordered pairs. So that's it for section 3.